Yeah, this stream seems to work. I hope at least it does. Yep, it does. Hey there. It does. Yep, it does. Yeah, hello there. Welcome to my stream. I hope um more people are gonna join. Oops. Oh yeah. Hi. Hey there. Yeah, haven't seen you in a while. Yeah, how are you? I just started the stream, so yeah, we're just getting started here. I mean, not with the project, the small project we already uh created last time. Yeah. So what we're doing here is yeah, a small layer one blockchain cryptocurrency, whatever, in Rust, obviously. And the thing is, I mean, I've never been actually a fan or something. I wasn't a pro of Web3, I think it's called, the decentralized internet, the decentralized stuff. And I mean, it's kind of it's some there's some trendy bullshit going on there, you know, smart contracts, and everybody's talking about them. And well, I was thinking like, I mean, how it works. Well, the normal explanation would be, well, there is a blockchain with which is a, well, basically immutable, well, it is mutable, but unchangeable data structure, and there is like consensus and whatever. And I'm like, yeah, but how does it actually work? I mean, how are, for example, the addresses generated? How, yeah, I mean, how and why? And all the, and you know, you're finding like a lot of general, I guess, AI stuff in the internet, but all the influencers, all the crypto pros, nobody really knows how it actually works. Nobody knows how addresses are being generated, what, for example, gas is, how states are mutated, how yeah, that any transaction is nothing but a deterministic function for general blockchain state change, for example, and I mean some mathematical formalities. I'm not a fan of them. I gotta admit, I don't like the formal descriptions because it very often doesn't tell you anything, but sometimes it actually makes sense, especially when you do not know how to address a problem. The first best thing you can do is try to write it down formally, and maybe you will find a way. That's what I do, for example. And that was basically the thing with this small blockchain. Funny enough, the blockchain itself isn't ready yet. But we already got a core here. So we're creating a couple of wallets here with private key, public key, their addresses. We are creating a Genesis wallet here, and we're doing some transaction with cold wallet creation. Basically a crypto wallet. I think Ethereum works pretty much very similar. I mean, I looked at how Ethereum works. And Ethereum only creates a wallet if you receive something onto the wallet. right? So until the some Ethereum weren't received, the null balance is basically the wallet does not exist in the memory, so we don't actually need, I mean, do we need to store it? We don't. So yeah, that what the overall state looks at the end. So basically the core is ready, and now we're moving to the one of the most interesting things, and which is actually handling the, well, again, transaction handling we can do, but we are moving to the blockchain itself. So the transactions, we gotta compile them into, well, I haven't streamed for a while. Yeah, we gotta compile them into a block. I believe, yeah, I got the block here. So block header, we have transactions. Oh yeah, we're exporting it just like this. Yeah. Yeah, again, I haven't streamed in a while, and I may be facing some, I mean, I may have forgotten some things, but whatever. Yeah. I actually also want to add some interesting stuff to the block, to my layer 1 blockchain, which is, for example, for extra gas, for extra payment, you can you will be able to allocate some space on the blockchain, and you will be able, for example, to store some files or any data, and yeah, or something like that. That would be cool. Yeah, allocate, I mean, like allocating, obviously, again, for some gas. Yeah, gas is basically yeah, the thing you're getting rewarded for. So yeah, where are we now? Yeah, that's so great. Node state, yeah, we're on transactions. We're running them transactions. So node state, node. Yeah, and the node has a couple of blocks. Yeah, it does. Sorry, the music's obviously too loud. Yeah, that will work. So insert self accounts. Yeah, the transaction is handled. Transaction pool.clear. So the yes, so we gotta store now the all the blocks and the blockchain itself. So I guess we could create a I mean, yeah, we got a vector of the block vector here, but I think it would be much more easier to create a separated object. Blockchain rest. Blockchain. Yeah, and I actually think, I think we can actually, instead of using a vector for storing blocks, I mean, we could go with a heap, I guess. Or no, but so yeah, we could go with a heap. I mean, yeah, remembering the arc, the algorithms data class. Yeah, we got a heap, and by loading and validating the blockchain. We just put the one block after another, and I bet we won't need the previous blocks. I mean, at the beginning, we will have to, well, load the blocks from somewhere. I guess from for the beginning, we'll just load them from the IO, from some file, whatever, or sync them. It doesn't matter now. Then we sequentially take each block, we validate it, and we put it inside the heap. No, sorry, heap. Sorry. Not the heap. The inside the stack. I'm obviously a bit tired now. Yeah, obviously we use the stack, and we put the blocks one after another into the stack, and that basically, yeah, solves the problem, because we don't need actually the blocks further down. I mean, we validated them once. Do we actually access them? I guess not. So we do with a stack which we have to import, I guess. Is there actually a STD first in first out? Yeah, something if FIFO. Box stack and heap. Rectangle. Box. I mean, the boxes described here, these ain't the boxes I mean, it's some kind of stack data structure. Yeah, STD collections, sets, hash map, hash set. Really? There is no way. There is no. Yeah, I mean, I know the costs and complexities, but really? So I gotta install an extra crate for? Really? Stack? No. Okay, screw it. I'm just gonna go with a vector. Yeah, I'm just gonna go with a. I'm just gonna go with a vector. I don't care. Okay, for now I'm gonna go with a vector. I mean, I would hope at least Rust would automatically sum it up, because the compiler, I mean, I don't like Rust particularly, but the compiler is pretty smart. We can all agree on that. So yeah, so add block, get latest block. Yeah, so a block contains transactions, and I think the transactions are not contained as a vector, but I guess these are contained as a tree or some structure. As I know, I mean, I'm pretty sure it's not I mean, that's not how the previous hash. Okay, so now the funny part starts. Got to drag it over here. Huh. Yeah, you block. Uh, um, Nothing complicated. Push transaction. I mean, we could. Okay, so we only. Um. And here the interesting part comes, because we have to somehow determine that the block is complete, which we have to use whatever. I mean, and that's the really complicated part. So we have to really determine the best algorithm for how do we know if the block is complete. In Ethereum, there is a so-called gas, um, which is some. I think it's equivalent to some Ethereum coins or whatever, which is basically I think it's kind of reward something for working with it. So as long, I mean, when we and when enough gas is collected, when enough transactions, enough big transactions or small, or when the size of the importance of the, I don't know how to describe, how do I describe it, but when the size of the importances of all transactions were is big enough, then then the block is completed. The thing is, um the complicated thing is, first of all, we currently have no gas here, and we somehow gotta continue working with blocks, and or for example Ethereum, you can run scripts and smart contracts, and any smart contract output is basically also some gas. So meanwhile, so yeah, proof of stake would beacon chain, the finally gadget, and the Casper FFG. It's justified. It's justified. Yeah, but there's some condition which has to be met. Roughly safe consider confirmed after. Huh? I don't get it. Huh? Consensus mechanism is used. Um. Yeah, I mean, there is, we could make it just easier and introduce a counter, and that would like really solve the problem because yeah, we just count the transactions, and after some small blockchain. Whenever you're submitting transactions, your goal when the block is completed after those transactions. When is block created? Automatically mining POS proposal. But who does this proposal? When is this proposal done? It has been added to the chain. Well, we first completed and then we added to the chain. Isn't it how it works? Visible in the latest block. How do you know the transaction is? I don't care, dude. I mean, how stupid is this thing? I mean, I would love to slur here around, but I don't want to. I don't want my stream to become like slurring around and telling the ChatGPT to shove that kind of answers up his back. Let's say it this way. Again, you can expect something. You can expect even something remotely useful of ChatGPT and interesting transactions. With this, see block now. That means has been created and has been included. Okay. We'll go with a counter for now. Screw it. We'll go with a counter for now. Transactions and counter. Yeah. 0. New Genesis. The counter. Yeah, we can go with it. We can go with it. So we have the block ready and the yeah.